this. All right, so this is example 3 in our 2.1 notes, and I told you to stop and pause, and I wanted you to try to do just go through the steps you should remember on finding equation of a line given 2 points on your own. So what you should have done on this problem is step 1 is to find your slope. So finding your slope, which is m equals your y2 minus y1 over x2 minus x1. After that, whatever you label them as, it doesn't really matter, but I'm going to go ahead 8 minus 3 over 7 minus negative 3. A negative times a negative makes a positive. So we end up with 5 over 10, which equals 1/2. So we now know that our slope is 1/2, correct? After that, you're then going to use point slope form. So point slope form is your y minus y1 equals m times x minus x1. So when I left you on Friday, you should have solved this, and then we're going over it now, okay? So when I plug in those values, again, what you plug in for x1 and y1 doesn't necessarily have to be the same order you put in here. It could just be what numbers you decide you want to work with. So sometimes I choose smaller numbers. Sometimes I just choose all positive numbers. But whichever one you choose, it doesn't really matter. Does that make sense? I'm going to go ahead and use the smaller numbers. So when I plug them in, I have y minus 3 equals my slope, which is 1/2, x minus negative 3. A negative times a negative makes a positive. Okay, remember your goal here is to get the y by itself. So I'm going to add 3 to both sides. And I'm going to distribute and combine like terms. So we have y equals 1/2 x plus 3/2 plus 3. Notice now we have a fraction situation here, right? What is the rule in order to add and subtract fractions? Their denominators must be the same, right? And if their denominators aren't the same, then we have to make them the same. Okay, so I'm going to circle this so you can know that this is what I'm going to simplify. So if I have 3/2, I need to make this into the common denominator. My common denominator would be 2. But if I multiply the bottom by 2, I have to multiply the top by 2. So this becomes 6 over 2. So 3/2 plus 3 is the same thing as 3/2 plus 6 over 2. Agreed? Yes. Fraction 101. Okay. 6 divided by 2 is still 3. All right. So now I can combine my numerators. So when I combine my numerators, that's now going to give me 9 over 2. So therefore, this leads to y equals 1/2 x plus 9 over 2 is what you should have gotten for your equation. Okay, fractions are our friends. So on your My Math Lab, it's going to most likely ask you for the fraction form. Just make sure you're reading the blueprint. If you don't see the blueprint, it's right underneath the little box typically. You also can click the view an example to see how they want the answer to be inputted. But 9 times out of 10, it's going to want you to put it in as a fraction, especially when it's a simple fraction like 9/2. Okay, so questions about non-real world problems, just straightforward process of finding your equation of a line. Okay, remember if you're watching on Zoom, if you click where it says view, you can click view and then make it full screen so that you can see the full window instead of a little tiny box on your Chromebook. All right, no one in here wants to join the Zoom, right? Y'all are good. Okay. All right, so we're going to go on to example number 4. Example number 4 is going to be our quote unquote real world example, okay? So in 1998, Toyota sold 1.4 million vehicles, and in 2007, it sold 2.3 million vehicles. Find the point slope form for a line passing through the points 1998, 1.4, and 2007 at 2.3, okay? when it's asking you to find the point slope form, it just wants you to write it in point slope form, which means that I can choose any point, but I also need to make sure that I find the slope first, because the key thing here is the slope. Okay, so you can choose either one of the points, but you have to find the slope first. So finding your slope, m equals, and I'm going to have 2.3 minus 1.4 over 2007 minus 1998. Okay, so if you have 2.3 minus 1.4, what do you get? 0.9. So you get 9/10. Okay, then you have 2007 minus 1998. It's going to be a negative. It's not 9. That was not bad. Sorry, guys. Pause. The kids' school is calling. Okay, so I corrected the whole. I didn't mean to put the negative. I don't know why I put negative. Who knows? All right, so back to what we were doing. We ended up with 1/10 as our slope, hopefully. So therefore, when you're writing it in point slope form, again, you can choose either one of these points for your point slope. I'm just going to choose the first one. So y minus 1 4/10 equals 1/10 times x minus 1998. And that is your point slope form. Again, you know it's in point slope form because you're using your slope and given points. Okay. Don't know why it came out in red. We're just going to roll with it for right now. Okay. Questions, comments, concerns? Yes. Oh. Okay, remember point slope form is your y minus y1 equals m times your x minus x1. And all I did was plug in my x1 and, my x1 and my y1, and I plugged in my slope. Huh? Okay. All right, any questions so far? Okay, the next part is it wants us to interpret the slope of the, not the slope, interpret the slope of the line. What does it mean? So when it asks you to interpret the slope of the line, it's asking you to define what are the units describing your slope of the line. So for example, what is your numerator representing? What are the units of your numerator and what are the units of your denominator? So when we got that our slope equals 0.1, okay? So 0.1 can be written as 1/10. It can be written as 10 hundredths, right? But that's not what it's asking. It's asking you, what does it mean in terms of this problem? Well, remember your slope equals the change in your y over the change in your x, okay? Your y values represent what? Well, your y values represent the number of vehicles sold, right? And millions. So your y are your millions of vehicles, correct? That's what your numerator represents. Your denominator is your time, your years, right? The year that it, the amount of time that it takes, the year that it takes, right? So when we interpret this, this is what you're saying. I have 0.1, but this is 0.1 million vehicles sold per year. So that's what it means to interpret. Interpreting means you're going to identify what does the change in your y represent over the change in your x. Okay. Questions thus far? All right, so we're going to keep it going with the next part. So the next part is asking us to further dive into the real world problem and explain why or why not, or how accurate is it to the actual value. We're going to look at one piece. I'm missing something in my notes. I'm sorry. It didn't show me a piece of my notes. I think I have it all now. I hope I do. Ah, still doesn't show it. Okay, here we go. All right. Do y'all see it? You're good? All right, it says in 1988, we have already know that. It says estimate the sales in 2004 and compare them with the true value of 2 million vehicles. Okay, so according to data and research, there was 2 million vehicles sold in 2004, and it wants us to estimate those sales. So when we're estimating those sales, we would be using our model that we created, which was our point slope form, right? So we're going to use that to interpret. Now, you see two new words. What are those words? Interpolation and extrapolation. Does anyone know what those words mean? Nobody. All right, I'm gonna tell you what it means. So interpolation is basically the answer that we get is within the range of our known data. It makes sense. Does that make sense? So it falls within the range of our already given output. Your extrapolation is the estimate outside of the range. Okay. Your interpolation means that this is a more reliable model to follow, where your extrapolation is making assumptions based on other factors that are coming into play. So we're going to use our model to see if it was within our range or outside of our range. So the model that we had was that from my first part, this is our model, y minus 1.4 times 0.x. Because we're plugging this into the calculator, there's no reason to simplify. Does that make sense? There's no reason to simplify, okay? Because you're using the calculator. Unless your heart just tells you to, then that's fine. So we're going to let our x equal 2004, because remember, your x's are you're changing your years, right? So we're going to let our x be 2004. So we had y minus 1.4 equals our slope 0.1. And now we're plugging in our x value. And our x value is 2004 minus 1998. So we're going to go through the process, and our whole goal here is to get what by itself? Y. Okay, so I'm going to pull up Sylvie. Here she is. And I'm going to evaluate the other side first, the right side first. So I have 0.1 times 2004. It's not a 4. And I did not write my 0.1, and no one was going to tell me. It's like y'all got a kick out of, like, let's just see how many minor errors this lady's going to make. I can guarantee you at least 2 a day. All right, so once I type it in, I get that this is 0.6. So now we're down to y minus 1.4 equals 0.6. So remember I said that's why there was no need for us to simplify, because we were going straight to the calculator anyway. So our next step here is to get y by itself, which means that we're going to just add 1.4 to both sides. And we get y equals what? 2. It is 2. So does this fall within our range? It does. Our range was from 1.4 to 2.3 in the span of 2007, right? So it fell in between our range. So this is a interpolation, because it falls within our range, which means that our model is a reliable model. Does that make sense? Okay. What could throw something off like this is that, like, let's say there was a part that Toyota can get and their prices drastically went high because that little piece cost so much, and it was like all these other factors. Then that's where that extrapolation would come into play. Uh, and if I'm saying the words wrong, just know that math is my strong suit, and give me grace in that area. Okay. All right. But overall, how do you feel just using your models, plugging in, and evaluating? Doable? All right. Let's move on. Okay. Up next is we're going to be talking about finding your your intercepts. So finding the intercepts of a line, there are a couple ways of solving this. I don't know if you guys remember when I showed you the formula in the very beginning of our notes. I'm going to go back to it really quickly because I want you to, how can I get to it fast? There we go. Like this. All right. So do you guys remember me saying, hey, this is not a very commonly used one, right? We don't really use this formula. But this formula is actually pretty useful to help you determine your X and Y intercept, okay? So the goal here is that if you can get your X, your coefficient and your constants all down to 1, then what's remaining is your X and Y intercept, okay? So I'm going to show you this model, but I'm also going to show you the model that you should have done in Algebra 1, okay? Just because I think it's a pretty snazzy way of doing it. And I will be very honest with y'all, like I really didn't learn this method of teaching X and Y intercept until about 4 years ago when I started teaching, not 4 years ago, 5 years ago when I started teaching it using a different textbook. And I was like, oh, that's a thing. Oh my gosh. But I didn't really dive into it until I was like, oh, if kids are good at finding least common multiples, then yes, it works great. But if you're not good at finding the least common multiple, guess what? Doesn't work so great, right? It's not going to be as effective. All right. But anyways, so in Algebra 1, how you learn to find your intercepts without solving for Y or solving for X is, depending on your teacher, hopefully, you were taught that when you're looking for your intercepts, that means that one value has to equal 0, right? So when you're looking for your X intercept, that means you're letting Y equal 0, right? And that's because when you write it as an ordered pair, it is X comma 0. When you're looking for your Y-intercept, that means you're letting X equal 0. That's because when you write it as an ordered pair, it is 0 comma Y. Does that make sense? Okay. So when we have 3x minus 5y equals 15, and it says to find your intercepts, I used to call it the fist of 0. Okay. So with the fist of 0, you essentially are just going to cover up the one you don't need. All right. So when it's written in point slope form, if I needed to, I'm going to use a highlighter to represent my fist of 0. And then I can erase it. If I need to find the x-intercept, I'm going to use my fist of 0 and I'm going to cover up the y. That's because anytime you plug anything for 0, what ends up happening? 0 times anything is 0, right? And it becomes 0, the Casper friendly ghost, and it goes away, right? And so now when I'm looking for my x-intercept, I'm just solving 3x equals 15. So this would lead me to, so to find the x-intercept, I'm solving 3x equals 15. And what would x have to be? 5. X would have to equal 5. So my x-intercept is at 5 comma 0. Okay, that's how your fist of 0 works. Since I can't physically put my fist over the negative 15 for you, that is why I scribbled it out. Okay, so now I'm going to erase it. All right, now for your y-intercept using the fist of 0. So for y-intercept, I'm going to put my fist of 0 over the x term. And then what am I left with? Well, I'm left with negative 5y equals 15. So therefore, what would y have to equal? My y would have to be, what kind of 3? Negative 3. So my y-intercept is at 0, comma, negative 3. That's how the fifth of 0 works. And what you're doing is you're substituting in 0 for x and y, but we call it the fifth of 0 because it's going away. I'm punching it out. Does that make sense? Finding the x and y intercept. All right. The next way I'm going to show you, you do not have to write down. I just wanted to show you that how that formula works, okay? So with that formula that we had, essentially what you're asking yourself is for the least common multiple between 3, negative 5, and 15. So least common multiple between 3, 5, and 15. Do you guys remember finding least common multiple? Does that ring a bell? Yeah? Okay. Least common multiple, you're asking yourself, what is the smallest number that all three of these numbers equally divide into? And in this case, the least common multiple is 15. Once you have your least common multiple, you're going to divide everything by the least common multiple. I forgot this is my no right zone right here. Oh my gosh. Let's try that again. And now we're going to divide. That says divide. Trust it. So we have 3x divided by 15. And we're going to put minus 5y divided by 15. And we have 15 divided by 15. And what do you notice when you end up dividing? Well, you have to divide everything by negative 15, I'm sorry. And that's to ensure that your, I don't want to do doing this the wrong way. I'm going to remember this method if it kills me. It's supposed to be faster and quicker. We're going to see if it really is, but I don't think it's going to necessarily be. So what ends up happening is you reduce 3, negative 15. It's not negative. Did my pen right? My pen will not write, guys. Do y'all see? Nope. Where can I write it? Technology sometimes is like the vein of my existence, but also I don't know how it would function without it. Is it writing up there? Okay. I was sorry. I did not mean to divide by negative 15. There we go. We got to keep it positive. There we go. And that's going to be a negative 3, and that equals 1. And notice that under your x is 5, under your y is negative 3. And that is how the x-intercept formula works. But it starts off with finding the LCM and dividing. I personally like the fist of 0 and punching it out. How do you feel? Okay. All right. So keeping it going. Again, what did I say about this method? It was just a tidbit, right? Plugging in, this is our goal. Our main, this is our bread and butter right here. When you're looking for the x-intercept, y equals. When you look for the y-intercept, x equals. The reason why I want you to remember that is because that applies to every single function. Does that make sense? Not just linear, every single function. Whereas for linear, this method only applies to linear functions. Does that make sense? So I want you to use the one that applies to every single function, which is this guy. All right. But I just wanted to introduce it to you just in case you're like, I learned something different in life. All right, example 6, find equations of vertical and horizontal lines. When you're finding equations of vertical and horizontal line, I'm going to go back to our homepage. So don't freak out on me. I'm going to come right back to this, but I want you to remember what I wrote down on the first page. Okay, on the first page, we talked about vertical and horizontal lines. When you have vertical and horizontal lines, all you're simply doing is identifying what is the x and what is the y. Okay, so here, if it asks you to write a vertical line, the equation of a vertical line, all that is whatever your x equals is your vertical line. When it asks you to write the equation of a horizontal line, it's whatever your y is. Does that make sense? Okay, so horizontal is a function with a 0 slope, and it's going to be y equal whatever the constant is at y. Your vertical is not a function. It has an undefined slope, and it's going to be whatever the x is. Okay, so that's all there is to it. There's no way of calculating it. There's no way of doing any of that. So when you come over here and it asks you to write the vertical, so our vertical, that's going to be our undefined slope, and it's going to be whatever x equals. And what is our x equal? -3. Okay, then it says to write horizontal. Your horizontal is your line with a 0 slope, and it's y equals, and what is your y equal? 1, and that's it. It's more of a vocabulary thing. Oh, sorry. On example 5, did anyone need to see me plot the points and graph? Are we okay with graphing and connecting lines? I didn't. Huh? It wouldn't hurt to see the graph, okay? Well, then let me make room for it. So again, remember, my university kiddos, just unmute yourself, ask me questions, make a comment, whatever you may need, because this is your class just as much as it is the ones in person. All right, so here it says graph the line. What makes it nice about with your y-intercepts is that when you're graphing the line, you only have to worry about the x and y-intercept. So if I'm graphing, I'm going to go to 1, 2, 3, 4, 5. I'm going to go down to 1, 2, -3, and then pretend that this is the straightest line you've ever seen and that I went through both points. Okay? That's what makes the ease of graphing with your x and y-intercept. This is all you have to worry about is where you're at on the x-axis and where you're at on the y-axis, and then connect them. Okay, so now do we feel confident about graphing the line with x and y? Okay, all right. Speak now, forever hold your peace. All right, parallel and perpendicular. Coming from geometry, you should have learned that parallel lines and perpendicular lines have special traits when it comes to their slope. Parallel lines are going to have the same slope, right? They're never ever going to touch, and because they're going at the same rate, so we're never ever going to touch, right? Perpendicular lines have opposite reciprocal slopes, okay? Opposite reciprocal means that one is positive and the other is negative. That's what makes it opposite. And reciprocal means that your change in y and change in x are flipped. They're reversed, okay? Do you guys remember these rules from geometry and algebra 1? Yes. Thumbs up. No thumbs up. No, we never learned this. Can y'all hear me at university? Yes. Okay. Thank you for a thumbs up. Appreciate it. All right. Does anyone need a moment to write this down, or am I good to keep going? Good? Keep going? Okay. All right, so we're going to apply our rules here. So for example, we're going to start off with find the slope in slope intercept form of the line parallel to 3x plus 1, okay? So to find the slope of something that is parallel, that's the key thing here. Make sure my highlighter is a good color. Parallel. Parallel means that the slope is going to stay the same. Does that make sense? So our slope is going to be the same, but now we have new information. Our new information is that it needs to make sure it goes through 2, 1. So, oh my, if I'm giving the slope and a point, what do I do? Anybody? Everybody? If I'm given the slope and the point, what do I do? Somebody, anybody? I'm giving the slope and the point. What do I do? You use point slope. You're given a slope, you're given the point, you're going to use point slope. Okay. I'm given the slope, I'm given the point, I'm going to use point slope to figure out my equation of the line. Okay. You guys wanted to make that harder than what it was. Killing me, Smalls. All right, so I'm going to plug in what I know. I have y minus -1 equals, the slope is the same, x minus 2. A negative times a negative makes a positive. I'm going to subtract 1, and we're going to distribute. So we get y equals 3x minus 6 minus 1. So my equation of the line is y equals 3x minus 7. Yes, no, maybe so. I see some writing. I see some napping. Okay. Gonna keep going. Yes. Mhm. All right. So that's our parallel example. So let's look at our perpendicular. So for perpendicular, so notice this time it says we're perpendicular. And because we're perpendicular, that means that we have opposite reciprocal slope. So our slope is not the same. Your slope is going to change, okay? But the point that we're using is 1, -1. So the first thing that we're going to do is identify our new slope. So our new slope, if this is positive, our new slope has to be negative. And if it's 1/3, our new slope has to be 3/1. So our new slope is simply -3. Okay. So for my new equation, I'm going to be using -3 and the point 1, -1. Oh my gosh, I wonder, what do I use when I'm given a point in the slope? I could never figure it out. Anyone? Oh, there's a whole form for that? That's crazy. Point slope, right? We're going to use point slope. So we're going to take y minus -1 equals -3 times x minus 1. Again, a negative times a negative makes a positive. We're going to isolate the y, distribute, and combine like terms. So we have y equals -3x plus 3 minus 1. So we get y equals -3x plus 2. Okay, so that's your parallel and perpendicular examples. Parallel means they're going to do what? The slopes do what? Stay the same. Parallel means your slopes are going to stay the same, right? Perpendicular means that your slopes they flip and they change signs, right? They're opposite reciprocal. Opposite reciprocal. All right? How we feel? All right. So here we have, this is find the slope intercept form of the equations of the lines that outline the rectangle with vertices 1, 1, 5, 1, and 5, 5. So this is where I'm going to pause because this is going to be you using a little bit of common sense and a little bit of math sense. All right. So you're going to find the slope of the intercept, find the slope intercept form of the equations of the lines that outline the rectangles with the vertices 1, 1, 5, 1, and 5, 5. My hint for you is to maybe draw a little sketchy sketch. Draw a little sketchy sketch. And then also realize that it says it's a rectangle. So where would my fourth vertex be? Vertex. Vertex. I said vertex. My fourth vertex be. So giving you a moment. I'm going to let you think, process. Okay. So when you figure out the fourth point, yeah. Okay. So you had to have 1, 1, 5, 1, 5, 1, 1, 5, 1, 5, 1, 5, 5. The key thing here is parallel, right? They have to be parallel to each other, which means that they have to be on the same horizontal or vertical. Oh, I did that backwards. Vertical, horizontal, because they're rectangles. It's a rectangle, right? And opposite sides are what? Parallel. Okay. All right. Now we're going to talk about how to do all of this using technology. Okay. So how do you figure out a correlation coefficient, how to figure out all of this? The last piece is using technology. So using technology, again, remember I told you that if you do not have a handheld calculator on you, you can go to our Brightspace, and on our Brightspace, I did include a link. I also embedded, but sometimes the embedded one doesn't work. So if you just click the online one, great, because sometimes the embedded one is a little glitchy and it doesn't work. So I just put the direct link also. So see, oh, there it is. So either way, you're going to use either one of them. But if you are at home and you don't have one on your own, here's your option to be able to have the calculator. Okay. So we're going to go through the steps of how do you find the line of least squares fit for your data and what is the correlation coefficient. Okay. So with our data, first thing we're going to do is create a table. So our table would be made up of our values. It doesn't have to be in any order. You just got to make sure that your X's and Y's stay together. Okay, so step one is to make a table. All right, we're going to be inputting this table into our handy dandy calculator. To input the table into our calculator, we're going to be using the stat button. So we're going to go to stat, and then we're going to press 1 edit. And that's where we're going to input our table into L1 and L2. Okay, so I'm going to open Sylvie. Turn her on. I'm going to reset her just to clear because I find it faster to just reset instead of going through and clearing things. So I hit second plus 712. Second plus 712. And I'm going to go to stat and I'm going to go to edit. In edit, I'm going to put my values in L1 and L2. So we have -1, 0, 1, 2 for my X values. Then I'm going to put in my L2, 4, 3, 1 and 5/10, and 1. Okay. My, in theory, hope is that you would have done this in Algebra 2. But. Okay. So with the new calculators, in order for us to be able to see our correlation coefficient, we actually have to turn it on, which is kind of weird to say. So we're going to turn on our diagnostics. So to turn on the diagnostics, we have to press mode. Do you see where it says stat diagnostics? You're going to scroll down here to where it says Stat Diagnostics, and you're going to turn it on. Okay. So in order to turn it on, we're going to have to press the mode button. That's how we'll turn on. Okay. So now that those are on, we're now going to find our model. Okay. Are we all good? Can I keep going? Yeah. All right. So step 5. I tried to write it all over here because I knew Sylvie was going to be there, but I did not leave myself enough room. So I'm going to write step 5 right here. So for step 5, we're going to go back to stat. But this time we're going to go over to, see where it says calc? So we're going to stat and we're going to arrow to calc. Okay. Since we're looking for since we have a linear regression model, we're going to be using 4. We're going to press 4 for lin reg. Okay, so do we all see where I'm saying 4 for lin reg? So I'm going to press 4. And remember, we put our x's in L1, our y's in L2. And then we're going to come down here. And this is like the lazy thing. Like you don't have to do this feature, but it's actually pretty nice. So where it says store regression equation, this is your option for the calculator to automatically type it for you. Okay. Could you type it for yourself? Yes. But if you want to use this feature, you press alpha trace and you can say, I want you to type it in Y1 for me. That's all that does. So alpha trace allows it to type it in Y1 for you. Now, I will be honest with you, on the online one, I have not tried the alpha trace feature. So I'm not sure if it's updated to that. Oh, it is. Good, good, good. But yes, so you'll press alpha trace and it stores it. And then we're going to come down here to calculate. All right. So step 6 is we're going to calculate. So we made sure all of our information is there and we're going to run the calculations. And it's going to, think, and it's going to create our model for us. Okay. Our correlation coefficient is this R squared value. Okay. So your correlation coefficient is your R squared. Your R squared value is good as long you want it to be as close as possible to 1. So for us, our R squared value equals pretty darn close to 1, right? 0.969. So what that tells us is that we have a good model, that this is a fairly good model. Okay, how do you feel about the technology piece? Then you guys have to talk to me. Like you stop me. You say, Miss Jones, wait, step 1, what did I do? Step 2, what do I do? I cannot read y'all's minds. I swear if I could read minds, I would be a billionaire, but I cannot. So you just have to talk to me. Negative. Because that's not your negative. Your negative is here. Oh. You're putting -1. That makes so much sense. Yes, you're putting -1 in the calculator. Okay. So now, if you did not do the store feature, what that means is that you just have to write down on paper what your equation is and then type it yourself. So if I didn't hit store, I would write down y equals -1.05 x plus 2.9. And that's my model, right? And then I would go to y equals myself and graph it because it says plot the data and graph the equation. So when I go to y equals, mine's already there because what did I do? I stored it, right? If it wasn't there, then I would just have to type it. So when it says to graph and plot, you see where it says plot one right here? Do we all see plot one? That just means you're going to turn on your plot. So you arrow up and you're going to press enter and that turns on your plot. So for step 7, we're going to graph and y equals. And then 8, we're turning on the plot. Okay, to turn on your plot, all we did was go up and press what? Enter. And notice that it turns bold. Now, because you are, that looks a little creepy, but we'll run with it. But because you are graphing statistical data, to get your graph a little different, there is an added step. That added step is instead of just going straight to graph, you're going to go to zoom, and then you're going to go to 9. The reason why we go to 9, if my calculator wasn't here, I would have more space to write. But because I'm trying not to write behind the calculator. I'm so sorry that I'm squeezing it in right here. We're going to go to zoom, and we're going to go to 9. The reason why we go to 9 is because we wanted to view our stats data. Okay, so again, now everything is done. To get my final thing, zoom. Do you see where it says zoom stat? I press 9, and it's going to create a graph version of everything. So it plotted the data, and it graphed the line, and I can see, okay, yeah, it's a pretty good fit. It's above some of my points, below, but it goes through a good portion of my points, and that's what it means for you to plot the data in graph, okay? I will go through the steps one more time from beginning to end. As I'm going through these steps, please, please, please ask your questions. If you do not ask your questions, if you do not say anything, I cannot help you. There's this saying of closed mouths don't get fed, okay? That's what it means. If your mouth is closed, your brain is not going to be fed by me, okay? All right, so let's start from beginning to end. Here we go again. I'm going to reset my calculator, second plus 712, okay? I know that if I was your pre-AP Algebra 2 teacher, that you should be able to do this with no problem, okay? All right, so I'm going to go to Stat, Edit. I input my data, -1, 0, 1, 2. I have 4, 3, 1 and 5/10, 1. So I made my table, I input my table. Step 2 is I'm going to go to step 2, stat edit. And then 3 is where I put in the values. 1. And now we're on step 4. I want to turn on the diagnostics, okay? If I do not turn on the diagnostics, I will not see that R² value. So I'm going to go to mode. I'm going to come down to where it says stat diagnostics. And I'm going to turn it on. Now that it's on, I'm going to go to stat calc for linear regression. Stat calc 4 for linear regression. Okay. There's the bonus step of alpha trace if you wanted to type it for you. Is it necessary? No, because can you type it for yourself? Yes. Okay. So here we did stat calc 4 linear regression. Now we're going to calculate. So I'm going to come down to calculate, and it's going to run the calculations. From those calculations, I can see that my slope is -1.05. My B is 2.9. I can identify my correlation coefficient. My correlation coefficient is 0.969. Your correlation coefficient wants to be as close as possible to 1. And this is pretty good right here. Next, I'm going to graph. In order to graph, we go to y equals. Because I stored mine, when I go to y equals, what is already there for me? My equation, right? If it wasn't, what would I do? I would type it in for myself. That last step is 8. We're going to turn on our plot. So we arrow up and hit enter, and that turns on your plot. Notice that it is bold. That's how you know the plot is on. Because we are analyzing statistical data, our stat data, we don't go straight to the graph. We go to zoom, and we're going to go to zoom stat. What zoom stat does is that it adjusts the window to fit our data and our linear regression model. And now I have plot the points, and I've graphed the line of best fit. Okay? And those are the steps. All right, questions, comments, concerns. I'm not trying to throw you on the bus or anything, but Unique, you should be a pro at this. Okay, so that is the end.